Hello everyone. Well, welcome to my channel. I do educational videos on this channel about subjects that you probably don't know anything about, but hopefully by now you've watched enough of my videos to know something about the reciprocal system of theory. This is video number 207 on the reciprocal system, and this is a system of theory that was first derived by Dewey B. Larson back starting way back in about 1930. He died in 1990, so he put in about 60 years of work putting this together, wrote a lot of books, a lot of articles, gave a lot of talks. The basic idea behind the reciprocal system is that we live in a universe of motion. The universe is not made out of matter, not made out of energy, but it's made out of motion. Motion, for Larson, is the relationship between space and time. So that sets up a reciprocal relationship between space and time, where space or time is the numerator and time or space is the denominator of motion. So motion is a fraction that has time or space as the numerator, space or time as the denominator, but space or time, space and time, which ultimately do not exist. They only exist together in motion. Kind of like if you have a box, that would be the motion. If you have a box, then you have the inside of the box and you have the outside of the box. And the inside would be like space and the outside would be like time, or vice versa. And it's a little bit more complicated than just a fraction between space and time, because both space and time can be multidimensional. That's what Larson calls coordinate space and coordinate time. They both have 3 or more dimensions. And then there is also what you call clock space and clock time, which is the scalar aspect of motion and the progression. Clock space, we are familiar with that concept. The clock is always getting later and later and later and later. But so too, there is also clock space, where space is always getting farther and farther and farther apart. And then space and time both also come only in discrete units. There is no continuity. Space and time have a minimum size, a minimum chunk of space and time. They're both very small, too small for us to resolve, but nonetheless, they do not come continuous. They are only in chunks, and one chunk of space in one chunk of time is the speed of light. That sets up the speed of light as the midpoint of the universe. Half of the universe is actually moving faster than the speed of light, and half is moving slower than the speed of light. Larson calls the former the cosmic sector, and he calls the latter the material sector. So the material sector is a sector that we're accustomed to. We live in the material sector. We make our measurements and our observations in the material sector. But the cosmic sector is every bit as real, and it is every bit as pervasive. But we don't really see space, don't really see the cosmic sector. But we can extrapolate from the material sector because of the reciprocal idea that whatever is going on in the material sector is also going on in the cosmic sector, with the caveat that you just have to invert the roles of space and time. So for example, when you have the material sector, you have coordinate space, 3 plus dimensions of space, and you have clock time. The clock is getting later and later and later. But in the cosmic sector, you have coordinate time, 3 or more dimensions of time, and you have clock space. Everything is always getting farther and farther and farther apart. So they're the same, but the inverse of one another. And so we can take all the knowledge that we really have about the material sector and from the legacy scientists, and we can extrapolate it over to the cosmic sector. There has to be slight adjustment there, though, because we see space, but we do not see time. So what's going on in time, in coordinate time, we can calculate that, but what we actually see is its inverse in space. So, for example, if you have an exploding star, a supernova, of a cosmic star, an exploding cosmic star, that is something that you would see in, well, let's just say an exploding material sector star that goes beyond the speed of light, so that it starts to explode in time instead of space. We see an explosion in time as an implosion in space because we don't see time. We see how it affects space. And so that is really like the phenomenon of the white dwarf star. It is a star that is exploding in time, which we see as an implosion in space. So we see a super dense, very small object. Same thing with the quasars. Quasar is an exploding galaxy, which we see as a very small, compact object, very small compared to, the size of a normal galaxy. Larson actually predicted the existence of quasars, pulsars, and white dwarfs, but in particular quasars, years before they were actually discovered, back in the late 50s and early 60s. Okay, now we are going through his book that is called Nothing But Motion, and this is primarily about atomic physics. We've done a few of his other works prior to this. First, we did some biographical work of his, and then we went through his deductive development. So this is the step-by-step development of how he created his theoretical universe. He has these two fundamental postulates that he worked out over many years, the first of which is the primary one, and we went over that. The universe is made out of motion, and motion is the relationship between space and time. They have their coordinate and clock and discrete aspects. And then, so we went over his deductive development. He takes those postulates and he goes step by step, if this, then that, if this, then that. And so he arrives at a theoretical universe, which he then compares to the actual measured and observed universe of the legacy scientists. And then we also went over his book that is called Beyond Space and Time, which is his book on metaphysics. He's got chapters in there on all kinds of different things. It's a lot of it is an expose of the cosmic sector. And so he's got stuff in there on psychology, philosophy, religion, and many other subjects. So Larson has plugged in his theory to really every subject that he could while he was still alive. And there's more room for plugging it into other subjects, and some of his followers have done that as well. But today, again, we're looking at his 1979 book, Nothing But Motion, which is primarily on atomic physics. We are in chapter 16 of this book, which is called Cosmic Atom Building. And the first part of this chapter was very, very difficult. Certainly for me, I kind of got lost here. Hopefully we can pick it up here and a lot of times, don't give up, because sometimes Larson will get you lost, but then by the end of the chapter, he'll put together enough information that you can get something out of it. He might, like I said, I think he's a great writer, but he's not a great teacher. And so all the information is there, but sometimes he doesn't have it organized in the right order, or at least for my mind. And so, but if you stick with it, you usually can get something out of it. Okay, we're going to take over right here in a couple pages into this chapter. The existence of both two pion and three pion events has been given a great deal of attention because of the bearing that they have on the various hypotheses as to the laws that govern particle transformations. The present study indicates, however, that if the basic requirement, an excess energy environment, is met, so that conversion of the kaon to the material status is prevented, there are no restrictions on the fragmentation reactions other than those considerations that are applicable to matter and energy in general and in the material sector of the universe. The study of the transient particles, which had its origin in the observation of the cosmic rays, is now carried on mainly in the accelerators. It is assumed that the same particles and the same processes are involved, and that the details thereof can be more conveniently ascertained where the conditions are subject to control. This is true to a degree, of course, but the situation in the accelerators is much more complex than that to which the incoming cosmic rays are subject. The atom building process does not merely invert the decay process. The actual inverse of the cosmic ray decay is a situation in which material elements enter a cosmic or high energy environment and eject negative displacement in order to build up into structures that can ultimately convert to the cosmic status. The cosmic entities initially produced in this process are subatomic particles. The accelerators, however, produce the cosmic elements that are closest to conversion to the material status, such as C krypton, and then drive them back up the decay path by creating temporary energy concentrations in the flow or in the material environment, the low energy environment. Because of the uneven character of these concentrations of energy, cosmic atom building in the accelerators is accompanied by numerous events of the inverse or the decay character, and by various fragmentation and consolidation processes that involve neither building nor decay. Many of the phenomena observed in the accelerator experiments are therefore peculiar to the kind of environment existing in the accelerators and are not encountered in either the cosmic ray decay or in normal cosmic atom building. Okay, just keep in mind that a cosmic atom is the inverse of a material atom. It's a combination of motions, and cosmic ray is a cosmic atom that comes into the material sector due to a stellar or galactic explosion. And that cosmic ray, when it comes into the material sector, it automatically begins to decay because it is not stable in that environment. And so he's saying that cosmic atom building is the inverse of that process. So I'm trying to piece this together here. Keep in mind that I've read this chapter many times before, and I'm still, I was doing okay with this book until we got to this chapter, and I got lost real fast. So, okay, we'll keep going. It should also be kept in mind that the Actual observations of these events, the raw data, have little meaning in themselves. In order to acquire any real significance, they must be interpreted in the light of some kind of a theory as to what is happening. And in such areas as particle physics, the final conclusion is often 10% fact and 90% interpretation. The theoretical findings of this work are in agreement with the experimental results, and they also agree with the conclusions of the experimenters in most cases, but it can hardly be expected that the agreement will be complete where there are so many uncertainties in the interpretation of the experimental results. The sequence of events in cosmic atom building in the accelerators has been observed experimentally in the so-called resonance experiments. These involve accelerating two streams of particles, stable or transient, to extremely high speeds and allowing them to collide. The relation of the amount of interaction, the cross-section, to the energy involved is not constant, but shows peaks or resonances at certain fairly well-defined values. This result is interpreted as indicating the production of very short-lived particles, indicated lifetime of about 10 to the minus 23 seconds, at the energies of the resonance peaks. This interpretation is confirmed in this work by the agreement of the sequences of resonance particles with the theoretical results of the cosmic atom building process. Because of the difference in the nature of the processes, the sequence of elements in cosmic atom building is not the inverse of the decay sequence, although most of the products above C helium are included. As brought out last chapter, the decay process is essentially a matter of ejecting positive rotational displacement. There is also a decrease in equivalent mass, but the mass loss is a secondary effect. The primary objective of the process is to get rid of the excess rotational energy. In the atom building process, in a high energy environment, the necessary energy is readily available, and the essential task is to provide the required mass. This is supplied in the form of C krypton atoms, mass 51.73 mega electron volts each. The full sequence of cosmic atoms in the building process therefore consists of a series of elements, the successive members of which differ by 52 or 51.73 mega electron volts. Aside from the lower end of the series where two of the 51.73 mega electron volt units are required per cosmic atom weight unit, the only significant deviations from this pattern in the experimental results are that C boron 9 is absent, while C neon and C oxygen appear in lieu of or in addition to C fluorine. C meaning cosmic. The complete atom building sequence is shown in table 4. So here we are at table 4, and he's giving us it's called cosmic atom building sequence. Okay, so starts out with cosmic krypton, atomic number 36, and that is he rounds off to the nearest integer for the atomic mass of in cosmic electron volts. We probably shouldn't have done that because it just makes it a little bit more confusing. But C krypton is a mass of 52. Then the next one is C argon, element number 18. That is 103. And then we have C magnesium, atomic number 12, and that is 155. Then he throws in parenthetically C neon, which is atomic number 10, and that number is 186, which doesn't at all match up with the 52 interval between them. But the next one, C fluorine, atomic number 9, does. And so that is 207. Then he throws in another interloper, C oxygen, atomic number 8. And this one is 232, which doesn't match that. And then C neon, C nitrogen, atomic number 7, does not fit into the sequence either, although it's fairly close, 266, where you would think it would be 259. The next one, C carbon, atomic number 6, does fit it back into the pattern at 310. And then cosmic boron, 10, cosmic boron 9, cosmic beryllium 8, cosmic beryllium 7, cosmic lithium 6, and cosmic lithium 5. And these all fit relatively closely to the overall pattern, but not quite. So that's Larson's table, and we will go into the explanation of his table tomorrow when we resume. So thank you for tuning in, and have a beautiful day.